Alright, so let's take a look at the setup. We've got the oscilloscope on, we've got the probe here, which I'll connect in a little bit to the main device. We've got the secondary camera connected up through GoPro. And just to be clear about how I'm controlling all that, it's all wireless, so I'm just doing it through my phone here. GoPro, connect camera, so I can see exactly what's going on in real time. And then finally the setup right here. Let's take a look at that. So we've got the light source, which I've basically double-sided taped that down. I've got it to a ring stand. I was going to put shielding next time. I've got a ring stand on top of it, so that if I put something on top, what I plan to do is put the receiver right here, so it'll be about 2 centimeters from the surface of this device. And we've got our handy dandy ruler from City of Love, and I thought, why don't we have some fun with this, and instead of using a wire right away, let's actually use one of these. These are some one of these devices that you can get. And so we gotta take this apart. So I'm gonna, I don't know, I'm gonna try to see what I can do. It looks like there's a lip here. So I'll put that, I will take that apart. Alright, so I started chipping away at this thinking that there was a lip here. And there isn't. Apparently it just comes right off the top, like so, and you can see very easily the coil and the IC chip. We're just going to use that coil and attach that to our probe. So I'm just going to take that off and put that on our alligator clips on the probe. Alright, so we just learned something, that a standard alligator clip is just too big. Gotta use a mini grabber, so I had to go get my adapter. Didn't bring my full toolbox, at least not one of them. So we're going to, grab this one right here. And of course, like all good things, I shouldn't have taped this down, so let's move this out of the way. And let's zoom out. Look at that beautiful device there. It looks like a hot mess. And of course, a solid angle has to be perpendicular for this thing to even work. So we've got to can't help to notice this isn't quite behaving like, oops, I can't even see that. It isn't quite behaving the way I thought it would relative to the oscilloscope. Let's move in here. I took the camera down because I just couldn't see it. And if we zoom in, we don't see anything. Okay, so I gotta move the tape out. This is just too much. What I did, I know you couldn't see any of that, but I was trying to see if there was a sweet spot relative to this device, relative to the coil. I really had hoped that the coil, because it was for this kind of an application for NFC, that the coil itself would be optimized. And indeed it might be, but for this particular application, for whatever reason, it's not. I've even considered the possibility that the wires are touching with regard to the resin core, because I've manhandled this a bit, having come undone, but that doesn't seem to be the case, because I'm physically making sure that they're not touching. Anyway, so step number 2, I guess. Let's do it again. So let's take a look at this again. So this one actually is going to instead be one of these wires here. Why? Because it's already there. It's quite nice. And eventually I will grab a wire and strip it. But since we got this, and it's got the leads, I got the fine controller, the micro grippers there. What I like about this one is, I can make the loop. It's a big loop. I mean, it's bigger than any ring I could possibly. Come on. Come on. All right. Put it there. And you can just see it's just off the wall. Really quite nice. And I think this is going to work out well. And we see that, for this one, the sweet spot. Let's just, I'm trying to do this with one hand. So I just attenuate the signal, I decrease the amount of volts per division. Looks like the sweet spot is right here. Actually, right where my finger is. So it's that's where the best reception is. So I'm gonna make a note of that. It's quite easy. It's right there on the bottom bar of the NFC. So I now know where the best source emission for this source is right here. This wire seems to work the best. I'm actually inclined now not to even grab a piece of wire. This is going to suit my purposes nicely. Now I just need to double side tape it, put everything down, put the apparatus back together so I could put a sample holder, or rather my materials to be tested within, and get it all locked down tight as a drum. Alright, so let's take a look at what we got. Now, actually, it's not 2 centimeters. I actually had to lower this to about 1 centimeter off. The loop is being held in place by a tape platform with another piece of tape holding in place. By the way, this was just a joke. I didn't cut myself when I was doing that. That was insane. By the way, don't use a knife to open that up. You'll probably cut yourself. Let's take off. The joke's done. All right. So, the loop is actually, what's the diameter of the loop? It's a crappy loop. I guess everybody likes centimeters. So it looks like it's about, diameter is about 2 centimeters. It's not a perfect loop, of course. We could do a little bit better. So, I like this setup because it's already, of course, shielded. So I don't have to worry about, shorting or any mistake like that. Whatever reason, this did not work as well as I thought for some, whatever, such is life. So it's 1 centimeter off, 2 centimeters across, kind of in a loop, held together through a tape platform. Still allows, I think, a lot of space for materials to be slid in to determine radio frequency transparency. The platform itself is taped down, and this is also taped down. Now, as we can see, there's great sensitivity with regard to the angle of attack. This is a classic, I'm unable to calculate the solid angle of the radio field. Of course, if you're getting this certified, the test method, at least the test methods I saw for the ISO 14443A, all talk about calculation of solid angles. And the instrumentation created, what's that company in San Jose? FIME, F-I-M-E, or whatever. Their apparatus, of course, goes throughout a wide degree of theta to calculate the solid angle of whatever they're testing. We don't have that. This is simply got to be very careful. If I move this up and down, you can see that causes quite an effect with regard to the oscilloscope. So again, we're just doing with regard to the values of attenuation. So anyway, so here we got this set up. Let's just do another test. Here's my stylish Bitcoin card. I don't know, let's see if this, that doesn't attenuate as it should not. But this does, as it should. So we can definitely see that, oops, it attenuates. In fact, it's the magnet's right there. No, I'm an idiot. Attenuates. Okay. What other devices do I have that could fit in there? Well, we know, of course, that paper should do nothing, and of course it does nothing. So now, let me go get some other tidbits. Alright, so let's take a look at what we got here. We've got the setup. We're going to make sure that Faraday was correct. This is a piece of aluminum foil, or aluminium, whatever, however. Lo and behold, look at that, it works. So science works, so we can't go through a piece of metal, just as we thought. And of course, you know, a piece of paper, and of course nothing. So far so good. We've made no progress in advancing humanity's knowledge of the universe. Now here is where we got some fun stuff. I was going to make an iron solution, but got kind of lazy. I was going to get a cookie. Anyways, I did have this. I thought, why don't we try this? Iron shavings on a piece of paper. You know, spread out, whatnot. So, you know, there we go. And we know where the sweet spot is, and nothing at all. Now you might be saying in all these cases, oh, but you're not grounding your material, and I figure, well, a human hand is floating, most likely. You're wearing shoes. So I think that part of it is correct. Let me not kick my other camera. Let's see if this is anything is happening. And to do so, we've got to start playing with the scope. So first off, let's increase this so we can, you know, maybe, there we go, maybe see if we can see anything change. And because I got bad eyesight, not really, but you know what I mean. Let's put that right. Well, actually, I can use my I can use this to understand what's going on. Let's see. I think. Come on. I think we can. Well, that's pretty good. So we're just trying to increase the signal, see if we got anything attenuated. And look at that, we did see something decrease. Just by a little bit. I'm trying to make sure I don't try to disturb the wire here. I want to get over the sweet spot. Yeah, it does decrease. So it looks like this could be a profitable endeavor. Maybe if there's better grounding here, maybe cage it up with a properly situated Faraday cage to try to decrease any extraneous variables. Also, the wire itself needs to be secure. This needs to be really secured a little bit better, so that there's no movement, so you can have experiment to experiment reliability. And the scope itself seems actually pretty good. I wish. Oops. No, that's not going to work. Yeah, I mean, that's the best I can do for this scope.